Okay, so my plan, I'd like to just push through notes and give you a good amount of time to work on your assignment in class, if that's okay. Is that okay?
Yeah. Rhombus.
Okay. So congruent figures. What's true about two figures that are congruent? Okay. They have the same measures. And so they're the same shape, right? And they're the same size. Same shape, same size, which you said with measures. Okay. They could be translated, rotated, or reflected from each other, right? Any transformation that we've done so far, what you took your quiz on yesterday that I haven't been able to grade, anytime you did one of those transformations, your shapes were still congruent because they did not change in size. Okay, they just changed location and or orientation. Okay, so we're going to work on a couple things. Okay, we're going to kind of flip back and forth. What I want you to do is I want you to go to 110 and I want you to decide in number 1 on page 110, which of these shapes are congruent to each other. Okay, so if I talk about rectangle EFGH, is it congruent to another rectangle on there? Yes? Okay, now when I'm naming this congruent rectangle, I want to name it in an order that matches up with how I named EFGH. So there'd be a couple different ways we could do that. But if I go from E to F to G to H, how would we want to name that rectangle? VSTU. Yep, that sounds good. Okay. All right. Now, what about rhombus? MNOP. Is there a rhombus that it's congruent to? So I'm going to go MNOP, ABCD, or ADCB. Either way, it's fine. Okay. And then we have these two triangles. Are these two triangles congruent?
Yes.
Okay, so if I name it JKL, I think this one takes a little bit more thought for us to figure out how to get it there. PQR JK. Yeah, I think that sounds good. Okay, so how about you tell me, how do we get EFGH to VSTU? What kind of transformation? It's definitely a rotation, isn't it? It's oriented sideways, right? Okay. Then how about the rhombi? How do we get from this rhombus to this rhombus?
Translation.
That would be a translation. What about the triangle? That's also a rotation, right? Okay. So what we need to be able to do is look at a picture and figure out what the transformation is, okay? Are these two shapes congruent?
Yes.
Yes, okay. PQR and STU are congruent. What I'd like you to do, work together at your table. I'm gonna give you 60 seconds to see if you can come up with how we got from PQR to STU. It could be two different transformations. It would be stuck to the x-axis. You want it away from the axis. Okay, so I have a question. How is this triangle oriented compared to this one? Is it oriented the same way? Is it turned 90 degrees? Is it upside down?
Upside down.
It's upside down, which means what kind of rotation? Okay, so this means we need a rotation of 180 degrees. Yeah. Because there's more than one transformation. Okay, but I can tell that this triangle is upside down from this one, which means there is a rotation. So if I rotate it 180 degrees, we would have 4, 0, 5, -4, and 2. We would have this right here. Okay, there is my 180 degrees. Then what would I have to do with that red one? Translate it what? Okay, so we rotate it 180 and then we go down 5. right, let's see if this one goes any better for us. Okay, ideas on what this could be. Okay, if I rotate it 90 degrees, then I would be at does that look like it's oriented the same as this guy? However, if this one was up here, would it be like looking in a mirror? Ah, a reflection where? Ah, okay, so there's a couple different ways we could do this. If we reflected about the x-axis, you said? Where did you want me to reflect about?
No, reflect across two.
This guy?
Yeah, right there.
So if we reflect across that guy, then we would be here.
You just have to do
Translation.
Okay, so we could reflect where x equals 2, and then we would have to do a translation down. Is that what you said? Down 5. Ooh, that's might be really easy. Very interesting. Now, could we have reflected across the y-axis and then done a different translation? Yeah, we could have. So there could be a couple different correct answers. That's okay. You see what I'm saying?
reflect across the y-axis.
Mm-hmm.
Like,
Like if I reflected across the y-axis, it would have looked like this. And then I could translate it right and down. You see what I'm saying? Just that good, Ben. Just that good. Okay. All right, so I want you to go to the next page. I want you to plot ABC and DEF, and then together at your table come up with if they are congruent and what the transformation would be.
x-axis. Just for
Just number 4. I gave you too long. Are you guys talking about it with each other or just doing your own thing? Okay.
So like, the miles per hour. You don't understand.
I watched that movie yesterday.
Across the Spider-Verse?
Number 2.
Oh, The Amazing Spider-Man number 2?
Mm-hmm.
Andrew Garfield?
No, like the Spideyverse.
Oh, I thought when she said 2, The Amazing Spider-Man 2. Because that's on Netflix.
I stand by
My
it.
favorite
Andrew
English
Garfield
one
was-
too.
That's Tom Holland and Andrew Garfield.
I think Andrew Garfield is the best. A, he's funny, and B, he actually gets Tom Holland looks a bit young. And also Tom Holland.
Spider-Man is supposed to be.
No, Andrew Garfield is way funny.
Spider-Man's good.
Okay, are these two shapes in number 4 congruent?
Yes.
Okay. How so? Oh, they reflect over the x-axis. Is that all it is? Just a reflection over the x-axis? Man. Now, it's not a rotation of 180? No, because where would it go if it was a rotation of 180? It would be in the 1, 2, 3rd quadrant. Okay. What about number 5? I went ahead and plotted then.
Yeah.
Yeah, no. They're not even the same shape. One's a quadrilateral. Do you notice how K and N are the same coordinate?
Yeah.
And so it ends up being a triangle. Lame sauce. Okay. All right. Let's go back to 109. And we need to talk about a couple theorems here.
The theorem is gonna go with proof.
No proofs in this chapter. Proofs next chapter though. All right, so let's say K and M are parallel. Okay. What this says right here is that whatever our distance is between the two parallel lines, then if I rotate my shape, or if I reflect my shape across parallel line number 1, and then across again, parallel line number 2, then our distance is going to be double. Okay. So if I start a shape over here, reflect, reflect, as long as the lines are parallel, whatever the distance is between the two parallel lines, first point and reflect, reflect, last point are going to be double that distance. Are you following what I'm putting down?
Yeah.
Grid? The next thing is if we talk about K and M are intersecting at point P. So if I make the rotation and then I make the rotation again, now my angle is double from what this guy is. It's like this whole angle here is double what this cute little guy is right there. Okay, really the more important one is going to be that 4.2. Okay, so we're going to go back to page 111 and we're going to look at this right here. Okay. Okay, so if I'm talking about the segment UW and I say, hey, the translation? Which one is the translation?
I know, I think so.
What's a translation? Is a translation a slide, a flip? Oh, it's a slide. So UV slides to where?
Yeah. You. Wait.
Yeah, across the.
Is this a slide? Or is this a slide?
That's
This one, okay. So U prime, V prime, that segment would be the translation. Okay. Which lines are perpendicular to U double prime? So if I draw this line right here, which lines are perpendicular to that orange line that I just drew? K and M?
Yes.
Okay, that's part of that theorem, is that these end up being perpendicular to that distance, okay? Why is V double prime the image of V? Okay, the reason, well, how are we getting V double prime? We reflect across K and then we reflect across its parallel line. Okay, so since K and M are parallel, that is why we can do this. Now, if the distance, so I'm going to highlight it, let's do blue. If the distance between K and M is 5 inches, then what is the distance between V and V double prime? And we double it. Very good. Very good. Yeah, you did. Okay. Okay. Now, in this cute little picture with the keys, this guy is a 60-degree angle, which means this is also a 60-degree angle. Just throwing that out there. What is the angle of rotation that maps A, here's A, all the way to A double prime? What would that angle be? 120 degrees. Here again, we're doubling the angle. He says, no sarcasm in her voice.
Math is fun.
My favorite